Happy Wednesday, I think. I think today is Wednesday. At least it is for when I'm recording this video. Yeah, happy Wednesday, everybody. We're talking about solving exponential equations today. Okay, so make sure that you have a piece of paper to write on, and make sure that you have a calculator. Okay, I am going to be using this fancy schmancy one here, okay, with my calculators. But it's not actually necessary. We don't need to get a decimal answer ever. But just in case you want to, right? If you want to get a decimal, and I'm going to decimalize it also sometimes, it's good to have a calculator. Okay? If you're using your phone, then we need to learn how to use your phone and take these exponentials, equations and stuff. Okay, so there are two ways to solve exponentials. Okay, one way works sometimes, and the other way works all the time. Okay, so we're going to talk about them both because, well, it's important to know kind of both. So the first way to do this is, if possible, to make the bases the same. Okay, make the bases of the exponentials the same. Because if the bases are the same, then your powers have to be equal. Okay, and that's the one-to-one property of exponential equations. Okay, one-to-one property. So let's go ahead and make these bases the same. So if I have base 2 on the left side, I want to write 16 as base 2 also. So 16 is 2 to the 4th power. 2 times 2 times 2 times 2. So 2 to the 4th. And when the bases are the same, that means that the exponents have to be equal also. So x to the 4th. So I'm looking to raise 2 to the 4th power to make it equal to 16. Okay, sometimes it's that easy, sometimes it's not. So looking at example 2, I want to change 27 with a base 3. Okay, so 27 is 3 to the 3rd power. 3 times 3 is 9, times 3 is 27. So that means that my exponents are equal when my bases are. So 4x equals 3. So dividing both sides by 4, x equals 3/4. Now remember, the domain of an exponential is all reals. So you can get positive numbers, you can get negative numbers, you can get zero, we can get fractions, we can get radicals, you can get a whole bunch of crazy things. Okay? Not with logarithms, logs have to be positive, but exponentials can be anything. Okay, our last example, we're gonna write, let's see, 32 and 4 do not have, well, we can't write 32 as 4 to some power. So we have to find another way to represent 4 and 32 with the same bases. Okay, it turns out that they can be done with base 2. So 2 squared is 4, and we still have the x plus 3 exponent, and 2 to the 5th is 32. So we're going to solve this equation. The exponents must be equal, so 2 times x plus 3 needs to equal 5. So this is a cute little equation that we can solve. 2x plus 6 equals 5. 2x equals negative 1. So x will be negative 1/2. Okay? So that's what we need to start with up here in order to make sure 4 goes to the 32 power. So in other words, 4 to the 2.5 power, that will get us to 32. Okay, and that's actually true. You can check it in your calculator that if we raise 4 to the 2.5 to the 2.5 power, that gives you 32. So really cute and pretty not too bad if you are able to write them as the same basis. Okay, if. Okay, that doesn't happen very often. So we can always, though, solve by taking the logs of both sides. Okay, now you can either take the natural log or log base 10, or you can take a special log. Okay, there are some teachers that will teach you to take the special log of every single one of them. Okay, I don't mind whatsoever. The answers come out to be the same decimalized answer, but they will just look differently. Okay, so for this first example, I'm going to do it both ways. Okay, so one way is just to take the natural log of both sides. So that gives us the natural log of 5 to the x equals the natural log of 22. So now we're able to apply that power property, the power property of logarithms, which says your exponent can come to the front. Okay, so we can't solve something. We can't take the xth root, right? That doesn't make any sense. But we sure can multiply something by x. So x times the natural log of 5 equals the natural log of 22. So no longer is your variable in the exponent. It is right down there on the same line as everything else. So this just becomes a multi-division problem, right? This is x times natural log. So if I divide both sides by natural log of 5, right, and put this into your calculator, that would give you the answer. In fact, let me do that for a second. Let me find where I put my calculator. There it is. So natural log of 22 divided by the natural log of 5, this is approximately 1.9206. Okay, so one way to do this is to just take the natural log of both sides. Okay, natural log, not caring about anything, just take the natural log. Your calculator can do all of these things to give you the decimal. Okay, now the other train of thought is, let's take a specific log in order to get rid of the base. Okay, so this is using that inverse property. So what we're going to do, since this is base 5, we're going to take the log base 5 of both sides. Okay, and as long as you do the same thing to both sides, that's perfectly mathematically legal. Okay, now this inverse property says that log base 5, when the bases are the same, the answer is your exponent. So x equals log base 5 of 22. Okay, looks completely different than it did a second ago, right? A second ago we had natural log of 22 divided by the natural log of 5. Now, if you take that change of base formula that we talked about the other day, right, when before your calculator could do this kind of stuff, if you took that change of base formula and you take the natural log of this divided by the natural log of the base, you get that same answer. Okay, it just looks a little bit different. There certainly is a lot less work to be done. Okay, there's a lot less work to be done. So maybe that's the way that you like it. So you get to decide whichever way you want to do it. The decimal comes out the same. Just be able to recognize your way with a way that's presented on a multiple choice test. Okay, that's the only caveat, is that your answer on that needs to match up whoever's answers made it. Okay, so I'll do most of these both ways. How about that? Okay, so if we're going to do it the elimination way, so we're going to take the log base 8 of 8 to the x, okay, equals log base 8 of 20. So all of this stuff cancels out, your log base 8s, and x is equal to the log base 8 of 20. Okay, nowadays, calculators can tell you exactly what that is. Now, the other way is if we just took the natural log of both sides. So natural log of 8 to the x equals the natural log of 20. Okay, we apply that property that brings our exponent to the front. So x times the natural log of 8 equals the natural log of 20. And then we divide. So x would be the natural log of 20 divided by the natural log of 8. Okay, decimalized, it's the same thing. Okay, it just looks a little different, right? This has a base. It's pretty simple, right? It's very nice. Wrap it up in a bow and give it to someone for a present. It looks good. Okay, and it's the same thing as this one down here. Just doesn't look the same. Okay, for certain number 6, okay, because it has a base of e, we want to take the natural log of both sides. Okay, and natural log and e, right, those have the same bases. So natural log and e is just 1. So the answer is x equals the natural log of 4. So whenever our base is e, then the natural thing to do is to take the natural log, okay, because that eliminates your e. So that's like the elimination. When you want to get rid of something, we're taking the log with a special base. So this next one, we'll minus 4, like minusing 4 from both sides. So 10 to the 3x equals 5. Okay, so the clean way is to take the log base 10. okay, of both sides. So we're going to take the log base 10 of 5, and we're taking the log base 10 over here. Okay, so log base 10 of 10 cancels out, and we're left with 3x. And on this side, we have log base 10 of 5. Okay, so log base 10, remember, is the common log, so you don't actually have to write 10 as the base. It is understood that if log does not have a base, then it is in fact base 10. So log of 5 divided by 3 is a nice, crisp, clean answer. Okay, now these ones are kind of the same, right? So here we have the base. The base is 4, so we're going to take the log base 4 of both sides. So that eliminates all of this stuff, and we're left with an x minus 5 equals log base 4 of 3. Remember, your calculator can do this for you. That's okay. So x is equal to the log base 4 of 3 plus 5. Okay. If you were to natural log it, it gets a little bit messier. It gets a little, it's not bad. It's not awful. But it takes a fraction because you're always going to be dividing. Okay. So over here, now it looks like we have a choice. We have this is a base and this is a base. So you can choose to log base 5 both sides, or you can choose to log base 3 both sides. Okay. Now, in this case, it might be more beneficial, if we just natural log it. Okay. And then you don't have to worry about which one is the base. Okay. You just natural log both sides. So that becomes x times the natural log of 3 equals, right, the power comes to the front. The power comes to the front, so we have something that looks like this. Sorry, I was just checking the time to see what's going on. So this, remember, this is a number. The natural log is a number. It's a decimal number, but it's a number nonetheless. So this would be like your coefficient. So I can multiply into here like that and stuff, and it's just fine. So x times the natural log of 3 equals x times the natural log of 5 minus 3 natural logs of 5. Okay. Whenever you multiply, you normally put, especially the variable, we always put the variable in front because, x natural log of 3 versus the natural log of 3x, right? Does the x go with the 3? I don't know, unless you have parentheses everywhere. Okay, you don't know if it's a coefficient or not. So just put the x in front for natural logs or for logs, right? Keep the x in front so that we're not confused anywho, it's just easier if you do it. So now I have two things that have natural log in them. So I'm going to get them both on the same side because you get your x's on the same side, right? This is just algebra with decimals. No one, of course, likes decimals, but algebra with decimals. So x times the natural log of 3 minus x times the natural log of 5, negative 3 natural logs of 5. So now that both of these have a coefficient of x, I'm going to factor that out. In my calculator, I would actually do this subtraction, and it would give me a nice decimal. Okay, and over here on this side, I would also put this into the calculator, and it would give me a nice decimal. So then if this is my coefficient, this subtraction problem, I'm going to divide both sides by this subtraction problem. Okay, no, it's not pretty. Okay, this is not going to be a gorgeous answer, but it's going to be the answer nonetheless. So negative 3 natural logs of 5 divided by natural log of 3 minus natural log of 5. And no, these can't cancel out. Okay, it has a minus in it. You can't ever cancel when you have a minus. That doesn't work like that. Okay, so this is how we do these. You can either just take the natural log of everything and you come up with funny looking fractions. Okay, fractions that look like this right at the top. Natural logs divided by natural logs, which your calculator can do, or you have logs with a certain base of a number, okay, which your calculator can also do nowadays. So either way you slice it, whenever we're trying to solve an exponential, you make it into a log. or you write them with the same base when possible, okay, which is not always possible. But logging, taking the log of both sides, always possible no matter what. Okay, there you go.